Non-ionic detergents are molecular substances. The molecule of a non-ionic detergent contains a grease-soluble component and a water-soluble component. So you have to have a hydrophilic portion. Even though it's not a charge, it still has to be extremely water-soluble. And then you have to have a grease-soluble part to react with the grease. And as long as you have the grease-soluble component and the water-soluble component, it can operate as a detergent. Biodegradability. And so again, whenever we use the word soap, we mean the salt of a carboxylic acid. All the other ones are detergents. Biodegradability. Organic substances that can be readily decomposed by microorganisms are biodegradable. Detergents with straight chain alkylbenzenes are biodegradable. However, if there's branches, they are not biodegradable because these branching methyl groups stop the microbes from consuming them. So which of the following substances is a detergent in water? A, no. C, no. B, yes, it's a cationic detergent. Phosphoric acid is similar in structure to carboxylic acids, and it forms esters and anhydrides just like a carboxylic acid does. And so here we see phosphoric acid. And this is especially important in dishwasher soap. They use a lot of phosphates. Phosphate esters form just like carboxylic acid esters form, but it can form 3 of them instead of just 1 of them. So here we have monoethyl phosphate, diethyl phosphate, and you can have a triethyl phosphate. And this is especially important in DNA and RNA, which typically have 2 phosphoester bonds. So we call them phosphodiesters. And so this holds DNA together. So DNA is linked together with phosphodiesters. Pyrophosphoric acid is 2 phosphates linked together. So you have 2 phosphoric acids that link up. And here we see it's like a double phosphate ester here. That is a pyrophosphate. And these are important in ATP, which is the universal energy source for organisms. The energy is stored in these phosphoanhydride bonds. And so chopping those bonds releases huge amounts of energy, which is why ATP is the energy currency of the cell. So show the product of the reaction of 1 mole phosphoric acid with 3 moles of butanol. You'll attach butanol at every OH. We have 3 ester groups. And that is the end of this chapter on carboxylic acids.